So thank you so much for the warm welcome, and it's a pleasure to be here. Let's wait what the internet... Okay. Thanks again for the warm welcome, Amanda, and thanks for having me. It's a pleasure to return to Brazil, and it's a pleasure to return to Ontopros. This is such a vivid community. It's always really fulfilling to come here and see the energy that ontology research enjoys here in Brazil. It's really inspirational. And I want to thank the organizers of ICBO 2023 and the organizers of Ontopros for inviting me. It's a huge honor to be a keynote in this excellent conference. And thanks again. I want special thanks. Just walked out of the door to Fernanda. She has been great in organizing this conference. Thank you so much for everything.
Welcome.
Thank you. So today I'm going to talk about improving ontologies to foster artificial intelligence in biomedicine. And this is a topic that comes up all the time in my practice as a biomedical informaticist in a hospital, where you talk to doctors and they say, well, we want to do something AI. And then you say, well, we could use something that's knowledge representation and reasoning. And then, no, I mean AI. So this really reminds me of a street sign that when I moved to Arkansas in 2011, my favorite park had this, oh, wait, sorry. I'm double dipping, so to speak. This doesn't, yesterday this worked, the clicker. I can also just, nope.
Yeah, you can pass in.
Okay. Awesome. Thank you so much. So what you see now was a street sign that was posted at a street in Arkansas, a hiking path, when I moved there in 2011. Hikers beware of snakes and animals. Like for us, yes. See, I hoped I would get a good chuckle out of this from ontologists. But this is actually really a situation, oh wait. This is really a situation that reminds me of the ontologies in AI. And it reminds me when people talk about ontologies and artificial intelligence, like snakes and animals. So in order to help everyone to be on the same page where I am, I want to give you my idea of what artificial intelligence is. And I think that's, and I'm open to other definitions. I'm not saying this is the one truth, but I think it's really important that if we talk about something that is such a buzzword as AI is today, that we just eliminate a little bit. What are we meaning? And by and large, I want to go along this, not a definition, but this kind of intersection of the area of what AI is as provided by Russell and Norvig, a kind of standard textbook on the topic. So you have these four areas that one is thinking humanly, thinking rationally, acting humanly, and acting rationally. And on the slide, you can see quotes that explain further what these three areas roughly encompass. And I think it's important to note that even there's a huge variability. There's a huge difference between what the people who investigate and finding out thinking humanly aspect of AI are doing, if you compare it to the people who look into acting humanly. In my talk today, I will mostly be concerned with methods that fall within the area of acting humanly, not the other four. You see that these areas here that are listed are natural language processing, knowledge representation, automated reasoning, and machine learning. As an ontologist, I feel I'm naturally working in the areas of knowledge representation and automated reasoning. I will kind of like talk a lot about these two areas and machine learning today. Now, when I was thinking what I'm going to say today, I thought, let's see what the people out there think about artificial intelligence. And I read a book a while back. It's not necessarily a science book, right? I mean, it's not a textbook that you would read in class, but it was rather interesting to get a business person's thoughts about how ontology and artificial intelligence interact. And the book is by Seth Early. He's an entrepreneur, runs a consulting firm for this kind of stuff. And it's called the AI-Powered Enterprise. And he states that the ontology is the tool that teaches intelligent machines how your business runs. I thought that was quite interesting. And he points out that machine learning algorithms may not always need an ontology to function, right? We see a lot of non-supervised learning that doesn't require an ontology at all. But he says in your business process as a whole, you require ontologies to link the results that you get to your actual business processes. And how to accommodate that, or how to accommodate that with your information architecture and data structures. Somehow that really spoke to me because I'm at the University of Arkansas for Medical Sciences, which basically is a hospital with medical education attached to it. And one thing that you really learn quickly when you work there is you're an academic medical center, you're not an academic center. And there are differences. This is basically run like a business. All of the data we collect is not, the data collection processes are not done like in a research lab. They are done for the business of helping people and billing people. It's a business. And I don't mean that in any way negative. It's just important to acknowledge that. And this is a little outside of the field of ontologies, but I'm the vice chair for faculty development. And something that I found in that is that new faculty members who come in, who embrace that from the get-go. There is a hospital operational side that functions like is business oriented to the job of healing people. It's not research at the forefront. We do research, we want to do research, we have to do research. They do better than people who still are in the mindset of this is a university. I mean, it is a university, but it's not comparable to a research university or an undergraduate institution. So that was why I think the book really spoke to me. And I was really wondering, talking about ontologies and machine learning, I was really wondering, so the people in our business, what are their interests? The University of Arkansas for Medical Sciences is a CTSA hub that is a huge funding scheme from the National Institute of Health, which funds specific hub sites to foster translational medicine. So to improve the way that we do research and then how we make the research results available to clinical practice on all staffs. It's often referred to as the bed to bench or bench to bed transition. The TRI, that's the institute at UAMS who does this. The TRI has an informatics service of which I'm the co-director, and we get help requests from researchers in our institution. And we looked at, I wanted to look at, so what do we get? Ooh, now I did something stupid. There we go back. So I looked at what kind of requests did we get? Sadly, 0 ontologies requests. Is that the truth? We got 16 requests for machine learning help. The cohort creation I just put in, that's irrelevant to machine learning or ontologies. That's the busiest area. Most people want cohort creation. The others is just like setting up a database, creating a RedCap instance. It's really IT, nothing that has to do with biomedical informatics. So we see that there is some interest in machine learning, that ontologies is terra incognita. I want to put that a little bit into perspective. These are people who typically have no collaborator in biomedical informatics. So they just come in there, what do I know, surgeons, and they say, oh, I'm going to invent a machine learning algorithm. I see that all the time. So, and then they say, well, maybe I need to talk to someone from informatics about that. You know how it is. So anyway, this is how it looks in my institution. And to put it into perspective, we have more people working with ontologies. We have more people working on machine learning, but they probably already collaborate with the Department of Biomedical Informatics and an expert. So I also, when I'm awake at night, I play around with PubMed a lot. So this is what you get at PubMed. If you look at this, you see that obviously what the author of the book writes has not really hit academic medicine very much, because it seems like there's a lot of work going on in machine learning, and there's a decent amount of work going on in ontologies. But the idea that machine learning and ontologies could somehow work together. 1,129 papers. I don't know. How many people is that? Maybe 800 people doing research on that. Hopefully everyone is in the room today who's doing that kind of research. But I think this is an under-researched area. If you read the book, you really get the feeling, yeah, he's onto something. There's a lot that could be done. And then you look at this and you think, I think we're leaving a lot of opportunities on the table. So going back to the book. So what should ontologies do in the opinion of Mr. Early? Well, ontologies should organize and translate information. I think this is the use case of ontology we're all like super familiar with. That's exactly our bread and butter job. They should provide the enterprise-wide vocabulary. Yeah, I mean, we're not focused on enterprises, but we go big. We have worldwide domain ontologies in the OBO Foundry, but yes, you provide a vocabulary. You should represent knowledge regarding the information structure, and you should link the results from other AI methods to the business problem. And then you should foster the analysis and interpretation for results generated by AI. So this is what Mr. Early says ontologies should and could do. So I extracted from that my view of what do ontologies need. So, and I think these are just the highest priority needs. There are other things ontologies need. Yesterday we had a very lively discussion about FAIR principles and how important it is that ontologies are accessible, and that still is not always the case. So ontologies need classes and axioms to foster the organization and the integration or translation of data. They need a well-built, user-friendly vocabulary, and they need representation of the information structure and the business process. The last one is probably the one where I'm going out on a limb the most. The other two, I think, are really, we could all agree upon. And the third one might be a little divisive, and I'm also honestly prodding this area, and I'm not sure what we can achieve there. So let's look at the first requirement for ontologies, axioms that foster organization and integration of data. This is a slide that many of you have already seen, because I always show that slide, and I'm still very grateful to Maggie Massery of the Children's Hospital of Colorado to provide me with that slide. What you see here is a list of different representations of blood pressure measurements in a hospital, in a pediatric hospital. So blood pressure in that hospital has 113 unique names. 15 of those have been deleted, yay. And 45 have been hidden so that people don't use them anymore. 52 are still available. And of those, 37 are actually used. 29 have been used more than 1,000 times. If you don't believe we have an issue with medical data, you should start believing this now. This is blood pressure measurements. It's a vital sign. It's very important. You need to query 29 different fields to get all measurements of blood pressure. It is one medical phenomenon. We're not talking about something that is difficult or obscure. This is what medical record data looks like. And this is my experience with UAMS medical record data too. This is what you get from the EHR. So we talked about providing the axioms, and here is a very simplistic solution, and probably not one that I would recommend overly, because this way you build a star model, but you could just say for each and every one of those values, this is something that is about blood pressure. And then you reuse a nice representation of blood pressure. In this case, I took it from the vital sign ontology. And there are others, and they all have their benefits and their not so benefits. But this is the kind of work that we would need to do to actually go into the medical data and provide these kind of axioms that help us to understand which things have something in common. Because this is important to note. If you look at the names of those, I know this is probably hard to read, so let me help out there. So you have things like EDU lying BP. Well, as a human, you could say, good, BP probably doesn't stand for British petrol here. It probably stands for blood pressure. But there's also PAP and other things that card BP, lying, different things. You have a full blood pressure. So it's not like it's for the computer immediately obvious that those are blood pressure measurements, right? And that is a typical situation, that we have names in our data headers for our tables that do not resolve, certainly not for the computer, and even with the humans, you need guidance, and you need to make sure you have someone who knows the data very well. So, okay, well-built and user-friendly vocabularies. Just as a teaser, I will come back to all of these topics along the keynote, and I will give examples from one of my current projects of how we do this, and that I hope will inspire some discussion. I'm now just running through what the problem is. So these are vocabularies that I looked up at BioPortal, and vocabularies are really bad. So you have the inexistent, example from Redlex, there's just no definition. I mean, honestly, either you know what incorrect patient ID is, or you have no business using Redlex. Get out. Yeah, that's common. No definition is a super common thing if you go to BioPortal. It's just assumed that the label will be absolutely clear. You have definitions that are circular. I was a little lazy. I didn't look long enough to find a fully circular one. The Eden definition of drug name at least throws in common to add something to it. But if the definition of the field drug name is name of drug, where's the definition? Where's anything that would help me if I don't know already what a drug name is? And that's the common we'll just get. That actually makes it a little hazy, because is the common drug name the common name of the drug, or is it the most popular brand name? Like in America, we have acetaminophen, and which, I don't know, in Germany it's paracetamol. And that's the name of the drug, but in America we call it Tylenol because that is the most common brand of acetaminophen. Similar with aspirin and the chemical compound. And then you have these clearly puzzling definitions. If you're giving a course on building vocabularies, use the NCIT as a bad example. The NCIT is so rich in bad examples, it's not even real. This one is a good one. So the definition of pregnant in the NCIT, observed to be or have been Pregnant. This means everyone who ever was pregnant is still pregnant. It's in the NCIT, pregnancy is the gift that keeps on giving. Pregnant once, pregnant for a lifetime. Yeah. So obviously not. So let's just recapitulate. We have a data issue in medicine. We clearly have a vocabulary issue in medicine, and there are people who are trying to resolve it. Yesterday, I was really honored to represent the OBO Foundry Operations Committee and give a talk about the OBO Foundry. And then I'm a contributor and I'm part of that committee. The OBO Foundry is a huge group of ontologists who agree to work towards certain principles in their ontology development. And it is a library of, the number was staggering. I think it's around, no, I'm not going to say a number. There are a huge number of ontologies in the OBO library. They're all accessible. They're free and you can reuse them. You just need to give credit to the people who developed it. You can even change the ontology for your own project and stuff like that. And the OBO Foundry principles are open. An ontology has to be open. I mean, I understand that in business and industries, we sometimes have ontologies that are kept secret. I do understand the rationale behind that, but I don't think it's valid. I think you get a better ontology in working with others than working in a small group. So the more the merrier. And I don't think the ontology will ever be the secret sauce to your product. I think that how you use the ontology might be the sauce, but the ontology shouldn't. A common format, that's a really important one. So an ontology cannot just be drawn on a piece of paper. Versioning, we need to know which version we're looking at. Definitions, so this is where the OBO Foundry actually cracks down and, hey, no ontologies with missing definitions. So Redlex is not a member of the OBO Foundry, obviously. Use of the same relations and all of those good things. Naming conventions. But you see that here, the OBO Foundry takes an active role in helping with these two aspects. The aspects where I think the OBO Foundry, and maybe some members are, but the OBO Foundry as a whole is still, could do a little more, is the representation of the information structure and the business process. And let me start with the business process. Because here I'm 100% on board. Yes, I actually think that many of the things we do in medicine and what they mean and how we interpret what they mean rely on the context. So you can do COVID testing in many very different medical contexts. And then don't get me wrong, there's no obscurity and this is a different kind of COVID. No. It's the same kind of COVID. It's probably the same kind of test. But your business process might be to provide treatment. Your business process might be to do research with that data and find out about the connection between COVID and diabetes. Your business process might be deciding whether a person can at this point be vaccinated or not. Your business process might be, should this person travel or not? Can this person enter this country or not? Can this person go into a cancer center or not? So those are all very different business processes. And I think that the way that we capture the data sometimes implicitly carries aspects of that. For example, which values you allow, how much detail you provide to your COVID testing might depend on which of those business processes you're ultimately interested in. So for the business processes, I really have no doubt that that is something we could do, and I think it's something we should do. I'm more skeptical about the information structure thing. And that I'm skeptical is merely like biographical, right? I'm an ontologist from, so to speak, the Buffalo School, and there you learn never mix up how you present some information and what things really are. So that's why I'm more skeptical here. But I'm totally open to start thinking about, similar to the context created by business processes, should and could we also think about how is the data collected and stored? That actually will be fairly strongly related to the business process. Is the data that we collect structured or unstructured? Do we use common data elements in the same information? And that can guide how we look at that data. So here it's more like, so this is the explorative part of the talk. And I'm like, I'd be interested to find out more. Interestingly enough, a few months back, nearly over a year back. Time flies when you're having fun. So I published a paper where we used this barn track coupe, which was developed and published by Bernd Plobel a lot as a part of our methods in a paper on orthopedic trauma care. And I cannot claim that I understand all of the details of this, but what I understand, what this tells me is that you have multiple layers and levels, and that your business process may need to be represented through multiple different ontologies, some of which are in the medical domain, some of which are in the legal domain. One of the areas I work in is informed consent, and this is really an area where the legal concern is more prevalent than the medical concern, and resource domain, and so on. And I'm showing this not to say, oh, this is the solution, but this is one thing that I'm going to explore over the next few months, maybe years, to see how we can use that in making our ontologies better. I don't think that this is a recipe to good quality ontology development, but I think it might be the final spice we can throw in to get this business process integration going. Because as you see, the whole business domain is clearly modeled here, and you have business concepts, and those play out in multiple domains. So we'll see how that goes. Okay, let's see. Yeah. Now I will show how a project that we're running now at UAMS, TIPTOE, is actually working in all of those three domains to improve ontologies. So a little bit of introduction to TIPTOE. TIPTOE stands for Trauma Institutional Priorities and Teams for Outcome Efficiency. It's good that it has an acronym. And the mission is to address two really important knowledge gaps in trauma care. Which organizational parameters affect patient outcomes in trauma care, and which organizational features are indicative of institutional commitment to trauma care? I'll not talk a lot about B today, because that's also starting a little further ahead in the project. The project officially started last September. We have already worked on the other, aspect A. So what we do ultimately is we aim to provide actionable information to answer those questions to stakeholders and decision makers. So this is not a research tool. This is a tool that ultimately gives people who decide on staffing decisions for trauma care, on how to plan a trauma center or a trauma care unit, give them information of how to improve their performance based on the data we collect. So in the trauma care in the US is organized in a way that we have 4 levels of trauma centers, level 1, 2, and 3, and 4. There are individual states who designate level 5 trauma centers. We're not concerned with those. Actually, in TIPTOE, we explicitly look at level 1 and 2. Those are actually similar. The difference between level 2 and level 1 trauma centers is level 1 trauma centers are academic medical centers. So they have a research component and they have an education component. Level 2s are typically larger cities, city hospitals. Both of these centers have all specialties available. So they typically have neurologists, they have hand surgeons and all of those things. If you go to the lower level trauma centers, they might not have all the trauma relevant specialities in their center. Okay. So the thing that really got us going was the levels are designated by the American College of Surgeons Committee on Trauma. So there's you could say, a verification process that looks at, do you really fulfill all the criteria? The thing that's really interesting is there is considerable variability in the outcomes between level 2 and level 1 trauma centers as a whole. And even just looking at level 1 trauma centers, there is variability. And same for level 2. So part of these results might be explained by external factors like the catchment area. So what is the area that your patients come from? That has to do with differences in injuries. In more rural areas, we see a lot of problems resulting from agricultural machinery, really not nice trauma situations. In the cities, you have gunshot wounds. I mean, we're in the US, right? You have gunshot wounds, you have knife attacks, all of those things. And traffic accidents, I think you have everywhere. Depending on your catchment area, if you live close to multiple interstates, like big roads, you might see more of those. And that explains outcomes because the severity and the type of trauma also has an effect on your public health aspect of outcomes. But we still believe that there is an impact on organizational parameters, and that's actually the hypothesis we're testing. So TIPTO is now in its 6th year. Before September 2022, it was called CAFE, and CAFE just laid the groundwork. We developed an ontology, talk about that in a minute. We provided an infrastructure to use the ontology to collect data in RDF. We provided a questionnaire for people to find out. So we basically laid the groundwork. Now it gets really interesting because this time around in TIPTO, we're going to collect a lot of data. That's the basic architecture of TIPTO and CAFE. So you have the representatives of the trauma centers. They enter data by filling in a questionnaire. That questionnaire actually shows them how other centers answered. So they get an idea of, am I weird as a trauma center? We call that a real-time comparison. The data that they enter is it's a questionnaire that does automatically create RDF. So we populate a triple store as we go along. In order for safety measures, we have a relational database running along, just storing the answers. So we could always recreate the triple store if we needed to. And we have done that. We switched servers, and honestly, it was easier to recreate the triple store than to transform it. And then data visualization. In CAFE, our data visualization goals were really targeted towards researchers. But this time, we're going to do something more exciting. I'll talk about that in a bit. So one part of the CAFE effort is that we created an ontology with a shared vocabulary. The ontology is called OOST. It's the ontology of, I need to look that, I should know that. It's for trauma systems and organizational structures of trauma systems and trauma care. There we go. And we created the questionnaire and tested the questionnaire with which we collect the data. And we had some visualization going that was more targeted towards public health researchers. So in TIPTO, we changed the structure. We have now 2 PIs. One is me, I do the data stuff. And Kevin Sexton is a biomedical informaticist and trauma surgeon at UAMS. He also does data stuff, but he also helps with the medical and clinical knowledge. We are using existing outcomes on outcomes data. So in America, all the trauma centers participate in a patient outcome improvement project called TQIP. That's short for Trauma Quality and Improvement Project. So they, every 3 months, send a whole lot of data to the American College of Surgeons anyway. And we just ask them to send the same data to us. And then the questionnaire, we scaled down from 100 questions to 40 because in trauma centers, especially level 2s without a research component, no one has time to answer the 100 questions. Okay, so the specific aims of the project are to determine the impact of organizational features of level 1 and level 2 trauma centers on patient outcomes. The second aim is to assess which organizational features of trauma centers are indicative of institutional commitment. Again, that hasn't started yet, I'm not going to talk about it. And to test the feasibility and perceived impact of a novel knowledge exploration tool, the TIPTOE knowledge path. So this is a study that is currently recruiting. The inclusion criteria, it has to be a level 1 and level 2 adult trauma center. We ask for data submission for the T-group data every 3 months, and every 6 months they answer the 40 questions. And the effort for our trauma centers that is important is 2 to 4 hours a year. This is what the TIPTOE questionnaire looks like. So we created chapters. You can see we have like 5 sections. And people can turn the comparative, for TIPTOE, people can turn the comparative evaluation off if they think that's off-putting or not interesting. And this is how we collect the data. Clicking these boxes creates RDF in the triple storm. We all in all collect 40 parameters. We're thinking of the future like we're the squirrels of trauma research. Yeah, we're the squirrels of trauma research. And in this project, we just look at mortality, length of stay, and major complications. If there are trauma people in the room or online, I know for patient outcomes and trauma, the other ones are way more interesting, but we stick with those because they're kind of the standard. This is the first outcomes you look at, but we collect more. So in the future, we want to analyze the other data. Yeah, and we will analyze these with descriptive statistics and multivariable regressions. Do me a favor, don't ask me about that. I'm not a statistician. There's information, and probably also information about the statistics if you go to this link. And I'm happy to connect everyone to Dr. Song, our statistician. It's statistics. Just... Okay, I'll leave that up for a second. And then you can always, do we share the slides when I'm... So the slides will be available, so no rush there. Okay, let's talk about OOST and its extensions. It's publicly available. It has a Perl, it's an OBO Foundry ontology, and it's funded by the NIH. So what we needed to capture are things like what are the roles and the rights and the obligations of a trauma medical director in a level 1 and level 2 trauma center. And here, probably not very good to see, is a job description for a trauma medical director that you would find in the job ad. So the competency questions we have is, so what are the obligations for a trauma medical director? What do they have to do? Do they participate in the evaluation of the trauma program manager? Or do they have to decide who goes on the trauma panel, the group of physicians that actually is responsible for trauma care immediately? What are the privileges of the trauma program manager? Can the trauma program manager kick surgeons off the trauma panel? So can they say, nope, you're not good, your performance is bad, your outcomes look terrible, you're out? And does the trauma medical director have the authority to staff the trauma panel? I already mentioned that. Can they decide who goes on? Yeah, that's just an example of how we use the DX ontology to represent obligations and authorities. That was an early example where we basically just used the term claims. A thing that's important ontologically here is that when we look at the way that we represent claims and obligations is their roles, but they're not the same kind of roles like job roles. So we made a distinction between institutional roles. That's the role in the institution, in your institution for which you're primarily hired. In my case, I'm a professor, so that's my role at UAMS. That means I have certain responsibilities. I need to wear a badge when I come to campus. I need to behave decent when I'm talking to staff, faculty, and students, and all of those good things. We see a few examples of roles here. Those are the kind of roles we look at in OOST. And then you have deontic roles. Deontic roles inhere in an agent, and they're externally grounded, and they express normative expectations. So with my role as professor, I also acquired some obligations. The obligation to teach 3 credit hours a year. It's an obligation. It's not the same as my professor role. It's a different thing, or it's maybe a part of that professor role. And similarly, I also have some, how do you say, I also acquired the claim to receive salary. It's kind of the nice part of the job, right? You get paid. And so that's also not me being a professor. It is a normative expectations. I expect around today, UAMS to give me my money. And I have good reason to believe they actually do that, which is nice. So all of this we actually gleaned from the document act ontology. I'm very pleased that one of the co-founders of the document act ontology is here today, Maurizio. And I hear we will see a lot of activity in this ontology in the future because he has more new use cases. That's super exciting. Document act ontology started 10 years ago, and it was a way to represent a theory of document acts. And that's a Barry Smith term. Basically, these are acts that bring about legal and normative entities. It's a BFO-based ontology. It follows the above-foundry principles, and it reuses classes and relations from OBI and IAO. It's also open, and you can take a look at it, and are welcome to do so. Here are the links. So we are reusing that ontology. One thing that we more recently did is, in the beginning, we really just had claims and obligations. But then we looked into a legal theory by an American guy called Hofeld. And that he separates out different types of claims. So, and he says there are always these pairs. So if A has a claim, then A lacks a no claim, and if A has a privilege. So a claim means that if you sell me your house and I give you the money, I have a claim to your house. The privilege means I signed a contract with the UAMS, so I have the privilege of collecting salary in a certain amount every month. A power is the capability of someone to change a claim or a privilege. The trauma medical director kicking a colleague off the trauma panel executes a power because the trauma medical director has the power. And this is why we actually needed to implement that in representing what trauma medical directors do from the perspective of obligations and claims or rights. Needed this distinction because some of the things trauma medical directors do are powers and some of it are claims. And immunity means that you have a situation where your claim or privilege cannot be changed. Not sure I have not encountered that in TIPTO yet. And then there are also correlatives. So if A has a claim, then B has a duty. If I buy your house and I give you the money, you have the duty to hand the keys over to me. And if A has a privilege, then B has a no claim. I'm not coming up with a good example for that now. Oh yeah, so B cannot claim to keep the money. UMS cannot claim to keep the money as long as I did my work. So, and if A has a power, then B has a liability. So if the trauma medical director says you're out of the trauma panel, then B has to carry that situation. And if A has an immunity, that means no one else can change their claim or their privilege. So this was an extension we did 2 years ago, and this is, all of that I already said. This is really important for the TIPTOE project because the way that we need to represent claims and obligations goes into this more distinctive legal theory where we have a difference between powers and, again, privileges I haven't encountered, but claims and, no, privileges I have encountered. Immunities I have not encountered. Okay. So this was built to really be able to lay out for each individual trauma medical director and trauma panel and trauma program manager that we encounter in TIPTOE data, to lay out all of these axioms that will ultimately help us to compare, to translate and integrate the data about those roles. Because make no mistake, a trauma medical director in one center can have completely different rights and obligations than in another center. This is also one of the leading use cases of why we started CAFE or TIPTOE in the past. So the American College of Surgeons, who's conducting these trauma center verifications, was invited to verify centers outside of the United States. And it didn't work very well because, for example, in America, in order to be a trauma medical director, you need to be a surgeon. In the Scandinavian countries, you have to be an anesthesiologist. So all of their centers immediately failed because they didn't fulfill this criteria. But I mean, you could represent that differently and say you need to have a certain level of medical certification and experience. It's not really important whether it's an anesthesiologist or
I repeat that question.
yes.
Hello. I would like to know you guys use knowledge graph visualization for your users.
Yes. So give me your email address because my programmers will be able to answer that. I can shed a little bit of light. We use mostly Python programming for transferring the data. And I'm not sure that we have found the final solution to represent the graph. We're still working on that. And because actually showing ontology or knowledge graphs sounds easier than it is, because you also get a lot of like white noise that is not interesting to the stakeholders. But if you give me your email, I can put you in touch with my programmer. I appreciate that.
We have 30 minutes to questions.
So I have a question, if you can hear me.
I'm curious on regard to the classifications that you have made. Oftentimes you have a set of enumerated classifications that maybe each institution may vary from one another. And in some cases, they have a well-defined system classification. In the beginning, you showed for patient outcomes, you have adopted a more standardized option, but for the experts in the field, the classifications seems that from your talk that they will be more refined from what was adopted. How do you handle these kind of classes of things like scenario values? Is it often that you can rely on a well-defined list of options, or you have to propose something to the institutions when they are talking in terms of
Thanks. I think I'm really glad to elaborate on that. So through the verification process of the American College of Surgeons, there is some standardization of what a trauma medical director is. We find that it's our opinion, it's on a very high level of granularity, right? I mean, I brought up the example of in Scandinavia, the trauma medical director as an anesthesiologist. In the US, it's really prescribed by the American Center of Surgeons. Guess why? That it's a surgeon. So so on that, so we have some standardization, but what we actually found is, how do you fill that role, right? How does the institution feel comfortable? And you know, sometimes authorities are not given to the trauma medical director, but to the director of clinical services, right? Because they don't want the trauma medical director to make those decisions. And they might have a good reason. It's not personal, it might just be the organization. This is exactly what we're doing. So we cannot, on the granularity level that we need, we cannot rely on pre-existing standardization. We need to capture that data for each and every trauma medical director. That's part of what we do with the 40 questions. Did that answer your question completely? Awesome, thank you.
Matthias, there is very
Yeah.
Hello, Matthias. Can you hear me?
Can you ask how?
I don't think you can hear me.
Can you, Matthias?
Yes, I can hear it. I can hear you, Barry.
Okay, great. So you make me proud, Mathias. That was a really nice presentation. Can you go back to the slide with the 3 bad definitions?
Yes, give me a second. I think we're already bringing up the next slide. Which definitions, Barry?
The 3 bad ones, the 3 examples that you gave.
Yeah.
So this is...
Yes. Okay. Yeah, sorry.
It's quite important because it makes me realize yet more clearly that I made a mistake all those years ago when I drafted the first set of requirements for the OBO Foundry. So one of the requirements was indeed that every term in an ontology should have a definition. But I now think that this is wrong. So I think that Radlex is actually doing the right thing when it doesn't give a definition for incorrect patient ID, precisely because that name is indeed self-explanatory. And many names in SNOMED, for instance, are self-explanatory. So I do not think you should criticize ontologies for not having definitions for terms which are self-explanatory. But then there's another issue which you didn't emphasize and which I think you should emphasize. So the EDAM example you have here is actually worse than circular. It's not just circular, it's also going to create the following problem. You will not be able to register an incorrect or an uncommon drug name. If you have a drug name in Mongolian, for instance, that will not be a drug name in EDAM, which it's worse than circular. It's actually excluding treating known cases, which are going to be quite important if you're dealing with rare diseases, for instance. So you should have a 4th category, which is worse than circular. And then you could put the EDAM example there. There are plenty of circular definitions. Not all of them are bad, because where a label is self-explanatory, then the definition may just repeat the label without being circular in a bad sense.
Thanks. Yeah, I agree with the EDAM example completely. I'm never sure. I think self-explanatory is always a tricky concept. I would agree that incorrect patient ID might not be the worst offender. Looking up these terms in the NCBO bioportal, there are lots and lots of terms who don't have labels, and I don't think all of them are self-explanatory. But
absolutely, yeah.
Okay, but yeah, you're right. The incorrect patient ID might not be the most difficult one. Thanks, Barry. I appreciate it.
You're welcome.
We have a question from Asia.
Mm-hmm.
Yeah, so Barry, I missed a little when you say that about not using definition. But yesterday we had a faulty workshop, and we had a survey on what is a good ontology. So I put out a form and everybody put in there, and a major stream of everybody's opinion is that a good ontology needs to have good definition, including textual and logical. So I might missed what you wanted to say, but even for this incorrect patient ID, for different parties, they may use different things to representing this patient ID. Therefore, we still need to define those terms.
Yes, so I stick by my diagnosis of this Radlex example. I still think that that is a reasonably good way of treating a term like incorrect patient ID. The best definition that you could come up with would be patient ID that is incorrect or something like that, and then you have a circularity problem. But suppose you have a better definition, supposing that you define it as patient ID in database number 273, which does not correspond to the generally accepted patient ID. That would be circular in the bad sense that I mentioned earlier, because now you can't use incorrect patient ID except in the very, very special case that I just described. So it can be that providing a definition makes things worse. However, I still stand by my original recommendation that you should provide definitions wherever. Well, I said originally you should always provide definitions. I would now say you should be happy to provide circular definitions or not provide definitions at all in those cases where the label is completely self-explanatory. And otherwise, I agree with the results of your survey. The best ontologies are the ontologies that have definitions, and the definitions exist in both English and in a formal language. I agree with that. Still.
Thank you.
Hello, it's Mara. Hi, Gary. I would like to reinforce the ideas that there is no self-explanation in the name of a term. When you work in an open world, and your ontology start to be connected with other domains, it becomes very important to have at least a dictionary definition what you are meaning of the world. I don't think that we have any term that's self-explanatory. Or you are considering that you are working in a closed world. I will do some ontology to be replaced by a system inside of it. Otherwise, there is no self-explanatory.
So I didn't hear all of that. The signal is quite bad. Matthias, can you just repeat the main point?
Yes, Mara said that she would say, similar to me, that it's hard to assess what self-explanatory is, and there might be no self-explanatory terms unless you work in a very closed system, right? I mean,
okay.
Yeah.
I think, Mara, I think you already mentioned that you should provide at least a dictionary definition. I would just say that dictionary definitions are created for quite different purposes from ontology definitions. And they are very often, of course, circular. Maybe they give a kind of reassurance to humans, even though when they're circular, they don't actually provide new information. They still give some sort of a reassurance. But I think that's irrelevant for ontology. So I think we should steer clear of dictionary definitions. The ideal kind of definition on the natural language side, the English side, is a semi-formal definition, where you, of course, you state the immediate parent class, and then you state the specific difference, which makes the child term of that immediate parent refer to those instances of the immediate parent term which satisfy the specific difference. So that's how a good English definition should look. And from that point of view, we could indeed create for Radlex a really good definition, namely incorrect patient ID equals definition patient ID, which is incorrect.
So, I don't know. You mentioned how your clinician partners were not necessarily happy with you putting about that. So, can you give me an example of one of your salient definitions, how you had to change it to satisfy?
Yeah, I mean, it's not only the definition, it's also, did the online audience hear the question?
No.
Okay, let me repeat the question real quick. Alexander asked, I said in my talk that the clinicians were not always happy with the Aristotelian definitions and they found those hard. And he asked for an example of what the problem was. And I will not quote, my memory is completely terrible, so I cannot recite an OOST definition. But it's not only definitions, also nomenclature, the whole thing with roles. And I mean, obviously, what we represent in OOST are the medical director role. So, and then the definition starts by is a role or is an institutional role, depending. And then it starts, and that's like, well, our medical director is not a role, right? So this is already creating a barrier for people who don't interact. It's important to say those clinicians were not the people we used to build the ontology, not the domain experts in the domain analysis. That I also love to share that. Like when I started Café, the clinical people for half a year thought I was crazy. They thought I was a complete lunatic because of all the weird. So what is this and this? Again, they thought about this procedural. Well, if this and this happens in the emergency room, you do this. And I said, but what does it really mean? They thought I was a lunatic. Eventually, they understood what I was aiming at, and we had really a nice 5 years of interaction. But the clinicians I was talking about here are people who are not involved in ontology in any form or fashion. And for them, Aristotelian definitions are just not helpful. And then also, those are not only MDs, those are trauma surgeons. They want to look at something and understand it in less than 3 seconds. Because otherwise, I mean, obviously not in this case, but they're used to, you take more time, your patient's dead.
You've been able to come up with definitions that fast.
Yeah, I mean, we used their expertise and we went back to the domain experts from the domain analysis and worked with them and went back to the preliminary descriptions we had and then worked with the community to improve what we had. Thank you. We have a question here, but we can go back to the online question once you found it.
Because some are writing.
Yeah.
They can speak with vice
versa
because everybody.
Yeah, exactly. While we dig that up.
So, thank you very much for your being very second slide, you made it so, and then you spoke about ontologies, right? And I'm usually is about the hidden background knowledge of, for example, in lots of complexity, because it's a very complex field, and I don't know, it's hidden in background knowledge.
Mm-hmm.
Like, for example, this message,
when I read Beware of Snakes and Animals, I know that snakes are also animals, but the probability that during my time I will see a snake is higher than seeing other animals. And I always wondered which artifact is responsible for this background knowledge. Our ontologies are machine learning algorithms. How do you deal with that?
Thank you. That's a great question. I actually think that this is the way that this sign was done is based on procedural thinking. Because honestly, in that park, most animals that you saw were deer and squirrels. And that's just cute, right? I mean, and dogs, of course. But that's the point. You're seeing a snake. I don't know how it is here in Arkansas. I mean, I don't because I'm, maybe I'm stupid. But in Arkansas, you tell someone, oh, there's a snake down the hiking path. They turn around. They don't even go near to it. I mean, there's snakes. Okay, that's just, so this is procedurally, this is like our trauma surgeons. Okay, if I see a snake, there might be a snake, so I need to watch out for snakes. It's procedurally the most important because seeing a deer is nice. Seeing a snake might be a threat to your life or your health. So but coming back to the actual question about the background knowledge. This is actually a lot of what we as ontologists need to do constantly, right? When I remember when I usually talk about ontologies for first-timers and I give a primer on what an ontology is, I show this inference model of how you can inference that something is a proton pump inhibitor, right? I say, well, you have a thing here and it inhibits this chemical substance or this chemical substance. So from that we can, and this chemical substance is a proton pump. So now we can infer. And then all of the people who know pharmacy are like, yeah, but that's trivial. And I said, well, it's trivial for you, background knowledge, but it's not for the computer because the computer doesn't know that. This is exactly, and this is what I'm always stressing. Your ontology needs to represent exactly those trivial cases. One problem with background knowledge is that it can get so huge and vast that you cannot really model it, but at least always take the things that are taken for granted and if they are domain specific, and then model those in your ontology, because that is actually really a huge problem. And I know it from the different side. If you teach people what ontologies do, they shrug their shoulders and say, well, that's just, everyone knows that. Yeah, but your computer doesn't. Thanks. Did that answer your question, please? Awesome.
People who critical sentence.
Oh, do I need to repeat? I'll repeat.
This is good because the same.
So the question to the answer I just provided was, how do I deal with background knowledge? Because a lot of the things that come into play are background knowledge. Is that a fair paraphrase? Awesome, thank you.
Okay, in fact, it's not a question, it's something, a comment on his comment, right? The point is how to embed an ontology in a machine learning algorithm, right? There are research on that, and I've seen good results, and I'd like to, but I can ask a question.
Mm-hmm.
Have you seen results about this, having ontology embedded in the machine learning algorithm, like word-to-vec algorithm, something like this, right?
So this obviously hinges a little bit on the definition of embedding, right? In the picture I showed, sorry, be there in a second. Man, did I create many slides. Okay, in the picture I showed, there is knowledge from the ontology, obviously part of that. But to speak more directly to it, in supervised learning, people have used ontologies fruitfully to define the kind of categories of things they're looking for. That is one of the areas where we see a lot of research that intersects between machine learning and ontologies. And then also, of course, you have a whole school of people who are using machine learning to create ontologies. those, and I'm not going to discuss whether that is successful or not. We discussed, Peter and I discussed that yesterday. I think that is an area that needs to be explored very carefully. And I think that ultimately, like in medical decisions, there needs to be some human intervention. But certainly in supervised learning, using ontologies has been done. And I feel it has been done with some success. Yep. Is it written? Oh.
Okay. I think this is for me. This was more of a comment when it was doing with the missing definition and whether or not certain ontologies should have some definitions. My concern is that if you were to use an ontology to guide a query, and while the label is self-explanatory, if you're setting up an initial query for the data, if there is a blank location, you would run into an issue where you're saying, look for the machine learning, include all the programs, look for all terms that have a definition that matches part of the terms. You start to get into an issue where if you tell the machine learning to get all definitions for relevant terms that are just by using the description, and the description is empty because the term is self-explanatory from the label, you're going to get into this gap. So again, this was more of a comment to the discussion that Barry Smith had earlier, but I still think that would be a case for having at least some definition or some secondary annotation just to make it easier for a query process on the ontology to be helpful. So.
Thank you.
I agree.
Barry, go ahead. Sorry, I didn't want to, I'm not.
Oh, I just said I agree.
Yep.
Okay.
Yeah. Oh,
yeah.
Okay, that was my bit. So thank you.
Thank you.
Thank you, Mathias, for your presentation. It was great. And in one of the slides, you said that ontologies need to represent business processes.
Yep.
And then what I want to ask you is, have you explicitly represent the business process in ontology? And if so, in which level of detail? Detailing the participants, the roles that are manifested, the steps. How did you do with that?
Yes, thanks. That's a great question. I have to admit, I'm still in my infancy with that. And actually, we had a talk on Monday in a tutorial that really inspired me to look more into that. We have modeled, of course, in Tiptoe some business processes. And when I say business, I mean like the business of taking care of trauma patients, like all of these obligations, right? They are part of the business process very much. But I think what we've done there is not highly systematic. And then I think I can glean some of the systematic part from our colleague that spoke on Monday. I think I'm in my infancy there, but there's more to do. I would love to say, yeah, I have it all figured out. That would be a blatant lie, so I'm not saying it.
Why can't you use headphones? A banja.
Oh yeah, you can just come here.
This is Stefan Schulz. Hello. Yeah, I just wanted to say some words about background knowledge, because I think this is very, very important. And I would go so far that I would say ontology is mostly background knowledge. And there's a very nice citation by Alan Rector. I think many people are or have known Alan Rector, who is one of the pioneers of biomedical ontologies. And he wrote once, most interesting knowledge is not ontological. And I think this is very important, especially if you look into certain ontologies, like, for instance, again, NCI tutorials, where there are things like, I think bladder cancer may have some pain and things like that, that often ontology languages that's used in order to express this non-ontological knowledge. And I think we have to be very aware to see where are the limitations of what can and should be expressed by ontologies.
Yeah, thanks. That's a wonderful comment. And I would just move with the may have. This is my pet peeve. May have is just people trying to outsmart logic, right? Because the OWL implementation of the NCI thesaurus is bound to description logic. In order to express may, you would need a modal logic. But the NCI people think that they're smarter than logic, so let them go ahead. But this is really an important point, and this is, I want to go to one slide real quick. This was, and this goes back to an Ontopras keynote I gave in 2019. It's really important that the ontology goes together with the data. The data has all of the it has the things that Alan Rector referred to as interesting. And that nowadays I have done different in the past, and I made mistakes and mea culpa and all of the good stuff. But it's really important to note that many things you shouldn't model in your ontology. Your RDF data will tell you that. And if it's not ontological, don't try to model it in the ontology. The real meat is combining the background knowledge that is that you drive with your ontology with your actual individual cases that you see, and then combining that knowledge together, drawing new inferences. That's basic philosophy of science, right? You have things that are known knowledge about humans, anatomy, what do I know, physiology, but then you also have your cases, and then you can draw inferences from the knowledge, what that means for the case. It's really beautiful if it works that way. Okay.
Professor Brochhausen, would it be possible to introduce in the scope of this ontology the indication of external factors in order to enable the connection with some externalities? For example, the one you mentioned, locational factors, which once addressed or translated in other organizational or professional contexts could have a significant impact in the context of trauma centers involved.
Awesome, thank you so much. Yes, that is a very good question. We haven't thought about that. I mean, here's the thing. There is a lot of research already going on with respect to trauma center outcomes in catchment areas, right? And most prevalent types of injuries. So we haven't thought about linking that in to our system. It is totally, I mean, ontologically, totally possible. We would need to add more data to it, because then we would need data about catchment areas from the institution, which right now is neither part of the TQIP nor about the questionnaire. But I think that is a very fruitful approach. Thank you for that comment. We really wanted, our feeling was like, everyone is looking at catchment area. No one thinks that maybe their organization is just suboptimal, right? Everyone just says, what can we do? Well, and we are going to try to find out what they can do. But I think bringing both together ultimately will give a very clear position. Thank you so much.
Time for one more question.
Next question online.
No.
Okay. So thank you again. I'm curious about how you handle commitments and claims. You said that you capture the roles attached to those commitments and claims. So does it mean that you do not model claims, and does it mean that you do not model the commitments and claims explicitly in the ontology?
Yes, we do.
You do.
But they're separate. What I was saying is they're separate. We created that distinction between institutional role and then we have the deontic roles, which are the obligations and the claims.
Então usar a frigideira menor, depois eu lavo as duas.
Maybe we have to mute someone online.
Yes. So we model those. That is exactly what we do because, as I said before, 5 people might have the institutional role of trauma medical director, but the set of obligations and claims that are related to them, that are related to their specific situation are different.
And all the delegations and all such.
And then delegations too, yeah.
And how you do that? Like, do you have like a concept that carries a piece of text that describes that commitment, or you can have a more refined version of commitment that relates to the people and institutions like who are relevant to that?
So that goes back to the RDF data, right? Because I mean that's the point. The trick with rights is I do not need to discharge my right in all cases, right?
Yeah.
I can have the right to vote in Germany, but maybe I choose not to vote. I'm not promoting not going to vote. Sorry, this is just an example. Don't try this at home. So I do not need to discharge that right. So there's no immediate way. You cannot write an axiomatic definition. This right is realized by this action because the right might not be realized. But in the RDF data, you can say, okay, the trauma medical director kicked Dr. John Doe off the trauma panel, and that realized his right to staff the trauma panel. So it's not that this is weighing what is ontological and what is not ontological. In the graph, you have it both, so you get a pretty clear picture.
And just a final comment. Within the limitations of RDF now, I understand that dealing with possibilities is it's quite hard to refile all those things. Have you considered within the design choices of the approach to include constraints that could be checked? So if I say that you have an obligation and you have an instance that violates a certain obligation, can detect that through queries and for check and stuff like that. Is that feasible? Is that an approach that you are interested in that concept?
We haven't implemented that yet. I was actually thinking about implementing some of these things using rule-based, so that we could see, okay, someone was actually violating or going above their rights, like the trauma medical director kicked off John Doe, but actually he doesn't have the right to that. It would need to have been done by the clinical service director. I thought about doing that with RAL, but other constraints might work. I'm interested to.
I'd love to continue.
Absolutely.
Thank you very much.
Thank you.